In my last video, I talked about how to use a multimeter to find the hot wire or source wire. Today, in part 5, we're going to cover running cables, or how do I determine what cables I need. Let's get started. Let's look at my installation. Yes, I know, there are tons of cables over here, and it looks pretty complicated. No worries. In a future video, we'll break it down, examine each cable individually, and put them together, circuit by circuit, till the whole thing works. For now, I decided to wire this up so that I could better illuminate my workspace to shoot this video, like this. Today, I just need to figure out what new cables I need, using this installation as my example. My original light fixture was here, just above where the mirror used to be on this wall. Notice how I installed a pot light to represent my previous light fixture. Now, this fixture was controlled by a switch over here. Obviously, there was already a cable going from this electrical box to this switch box to support this existing light fixture. I don't want to change this circuit. It's staying the same. On this light switch, the top rocker controls this light fixture. What I've decided to add is pot lights in the ceiling. I'm installing 2 pot lights. So that means I'll install 1 pot light here and run a cable to this pot light over here, then run a cable to where my source cable is over here in this electrical box. This type of circuit is called a series circuit because I'm wiring my lights in a single chain, one after another. There's another type of wiring method, a parallel circuit, which I might explain later if I ever decide to do that. At this point, I don't want to get into the weeds about the pros and cons of series and parallel circuits. For now, just know there are 2 types and I chose a series circuit. To complete my pot light circuit, I need a switch. So that means I need to run another cable, which I've done, from this electrical box that has both the source cable and the cable from the pot lights to over here where I plan to install a switch to control these pot lights, like this. The bottom rocker panel on this light switch controls these 2 pot lights together. Both pot lights come on or turn off together. Bottom line, I'll have 2 light switches here, one to control this light above the mirror, and the second switch to control the 2 new pot lights in the ceiling. To do that, I need to add 3 cables. I'm assuming you're working with drywall as your drywall surface too. Don't worry about creating holes in drywall. You're doing electrical work. You need access behind the drywall. You're going to be making holes. In fact, don't even worry about trying to limit yourself by creating small holes. If you have bigger hands, make bigger holes. It'll take just as much work later to repair small holes as it does to repair large holes. In fact, if you make bigger holes, you can actually do a better drywall repair job. Let me explain why. See this hole? See how I exposed the beam? The reason I did that is so that later, when I mount a piece of drywall to repair this hole, I'll have a spot to secure the drywall. Without these beams exposed, I need to create a brace like this with little pieces of wood to create a surface on which to secure my drywall. That's a more kludgy solution. Plus, how much does drywall cost? It's like 15 bucks for an 8-foot by 4-foot sheet. It's dirt cheap. The bigger problem you'll have is figuring out how to transport the whole sheet without breaking it. Now, if you have a flatbed truck, good for you. If you're like me, I don't. So I had to cut the sheets into 2 or even 4 smaller pieces to make it easier to transport. As long as each of those pieces is big enough to cover your biggest holes, you're golden. Keep in mind, drywall sheets are sold in pairs, probably to protect them from breaking too easily during transport. In my house, they used 1/2-inch thick drywall for walls and ceilings, and for the top floor, between the insulated attic and the top floor, the drywall is slightly thicker, 5/8 of an inch, and fire code rated. Look closely at the drywall used to construct your house and keep this in mind when shopping. For my exhaust fan, there used to be a switch and a receptacle over here on this wall. I think the cable for the switch went up this wall and then across and down into this electrical box. Then they installed the drywall and forgot to wire up a receptacle. Every washroom needs a receptacle, right? So what did they do? They dug a hole here and ran a cable across these 3 beams like this. See these holes? That's where they secured the cable. Yeah, Anybody can see this is a shitty solution, right? But you know what? It was done to code. The reason is they placed a thin metal sheet to protect the cable and layered tons of drywall compound to fix their half-assed job. However, this did create a new problem. All this drywall was extending out. This wall had a huge bump. Undeterred, they had a fix for that too. They decided to cover this whole wall with wallpaper. Now, to be honest, it wasn't that noticeable before I took the wallpaper down, but it was an unsolved mystery. When we decided to renovate this powder room, that whole house of cards came tumbling down. I removed the wallpaper and I was like, what the fuck is this? What is this huge bump? So first, I tried leveling it out with drywall compound, but it was still bugging me. I couldn't understand what the whole deal was. So then I decided, wouldn't it be great if the receptacle was moved from here over to here, close to the toilet, right? So I could sit on my throne and charge my phone at the same time. Even better, how about if I put the fan switch over here too? So if I drop a huge load, I flick the switch. Way more convenient, right? Discovering this whole problem was exactly the reason I wanted to do all this electrical work myself in the first place. We all hire professionals from time to time, and sometimes they make bonehead decisions. They don't tell us, they just do it. We pay them, and they leave, and we're stuck with their mess. How much more satisfying is having something done right? So, if I put my exhaust fan switch and receptacle here, what new cables do I need? When we look closely at this electrical box, we can see 3 cables. This cable provides power to this switch. It was a new cable I installed, and if we follow it back, it comes from our main electrical box here. Where the power comes in from our electrical panel. I need 1 new cable so far. When I press this switch to on, the power will flow through our switch to our exhaust fan via this second cable. That cable was an existing cable. It used to go over here, and now I moved it over here. Fortunately, there was a little extra cable length in the wall, and moving it to here wasn't a problem. For the receptacle, I need to explain some stuff. Since the mid-70s in North America, the NEC, or North American Electrical Code, has required that all washroom receptacles be protected by a GFCI, or a ground fault circuit interrupter. What does this mean? It means when building circuits in your washroom, all the lights and the exhaust fan can be on a non-GFCI circuit. However, any receptacles in your washroom must be on a separate GFCI circuit. If you have a jacuzzi or a hot tub, it must receive power on a dedicated GFCI circuit. For example, if a fault is detected at this receptacle, say someone has an electric toothbrush or a hair dryer plugged in here, and they drop it in water, the GFCI will detect that fault and turn the circuit off, protecting us from being electrocuted. Perfect. So to be clear, that means everything in this washroom, except this receptacle, can all be on one non-GFCI circuit, but this single receptacle needs to be on its own separate circuit, a GFCI circuit. Now, if you think about it, you'll wonder, well, what about the other washrooms in my house? Do I need a separate GFCI circuit for each one of those? The quick answer is no. There are a number of ways to cable these receptacles to code, and I'll go through them from cheapest to most expensive. My home has 4 washrooms: basement, main floor, main bath on the second floor, and ensuite. Each bathroom has at least 1 receptacle, and they're all wired together on a single circuit. To implement GFCI protection, the power travels from my electrical panel to this main bathroom receptacle. And here, a single GFCI receptacle was installed, about a $20 solution. From here, cables deliver power to all the other washroom receptacles in my house, and those receptacles are not GFCI. Why? Because if a ground fault is detected at any washroom receptacle, this GFCI receptacle, being the first receptacle in the chain, will trip, disabling the power. Did a light go off in your head? If your home is wired like mine, and I think many are, this might explain what happened the last time your hair dryer or whatever tripped the power. For us, we tripped the power one day in another washroom, and I went to the electrical panel and saw that all the circuit breakers were engaged. And I'm like, what the fuck? Exactly. This GFCI receptacle was tripped instead. Boom, there you go. Now you know why. There's another way to do this, and that's to simply change the standard non-GFI circuit breaker in your electrical panel with a GFCI circuit breaker. This solution is a little bit more expensive, $50 to $80, depending on the manufacturer of your panel. If you have an older panel, like say 30 plus years like mine, your panel either might not support GFCI circuit breakers or they might be too expensive, like $120 plus. Is this a better solution? Probably. I don't have enough experience with it. I welcome your comments below. When you do this, that means you don't need any GFCI receptacles on this circuit. Your GFCI circuit breaker protects all the receptacles and anything else on this circuit. For newer homes, this might be a code requirement in your region. The code keeps getting updated. It's good to check when you're making changes. A third way is to install a GFCI receptacle at every washroom. This offers the convenience where, if a single washroom trips the circuit is only disabled in that one washroom. Does this always work? I'm curious. Tell us in the comments below. I'm thinking if the local GFCI receptacle doesn't trip fast enough, another GFCI receptacle might trip further down the chain. I don't know. I don't have enough experience. To implement this, I think you just need one GFCI receptacle per washroom. For me, I would do just 4, so $80. If I have additional receptacles in any washroom, they would be protected by the first receptacle in that washroom. Get it? Another way, you could do both. Install a GFCI circuit breaker and GFCI receptacles. Is it safer? I don't know. It seems a bit overkill, but there you go. Getting back to my problem. How many cables do I need for this one receptacle? It turns out that the supply for this receptacle comes into my main electrical box above. If you've been paying attention, that means I have 2 different circuits supplying power to this one electrical box. So now I need 1 new cable to go from this electrical box to this receptacle box. In total, for the exhaust fan and the receptacle here, I need 2 new cables to supply power, 1 for each. Those 2 cables are now installed. There you go. We've determined what cables I need for my installation. Now you kind of already saw that I installed those cables. Perfect. I hope this helps you.